It's getting recorded, right? Am I audible? Hello?
Yeah, you're audible.
Okay, okay. Yeah, we can start then. The first problem. So our first problem is like we have to print the Fibonacci numbers, which are denoted by Fn, that form a sequence called Fibonacci sequence, such that each number is the sum of the two preceding ones, which are starting from 0 and 1. And for 0 they'll return 0, for 1 Fibonacci is 1 only, and for every n greater than 1, I mean from n equal to 2, you'll have this sequence. So you need to calculate f of n given n. So for them, for the input of 2 you'll have 1, and for corresponding to 3 you're having 2. One same goes for 4, you'll have 3. Yeah, any approach or queries on this? I think it's
One of the ways is the tabulation method.
yeah.
So maybe we can just try building an array starting from 0 and 1. And for the second index, we can just try to sum up the previous two indexes and then eventually return the f of n.
Yeah. So you want to share the screen? I mean the code or whatever you have written.
No, I haven't written anything. I'm just looking at it and I'm logged in via mobile, so it
Oh,
won't be
okay.
possible.
It's okay. It's okay. Yeah, it's that's also. Any other method? Anyone?
So general while loop will be also better here, right? Like given that it doesn't have any kind of constraint, just going with the like a recursive approach is taking stack in background as a memory, right?
Implicit stack.
Yeah.
Yeah.
We could have done with like taking two variables since there is no constraint. Like generally Fibonacci is like, I think if there is large number of n, then we go with a DP approach, or um, we check if the value is calculated, then just pick the value, don't recalculate it. So I think
Yeah.
no such constraint here. So I think this is kind of straightforward.
Normal recursion, right?
Yeah. But if n is too large, then maybe this can go forever. This recursion.
Yeah. For that, I think tabular method, which she was mentioning.
Yeah, exactly.
Yeah. We can pick that. And n, I think it's. I mean, not that less than equal to 30. I don't think so.
Yeah,
That's too big, right?
exactly. I was thinking that is there some kind of catch or some corner cases in this question, but this seems to be pretty
Straightforward.
straightforward as we
Yeah.
all must be knowing about this problem, I guess.
Yeah.
Yeah, I did it with three variables. So
Yeah.
it's pretty,
You can share it.
yeah. I need to
Okay.
log in from another computer. I'll share you in a few minutes, couple of minutes.
Okay. Okay. In the meanwhile, what I did, it's like normal recursion only. Like, but I think if n is large, that tabular method would work. Like you'll have to go to with the DP and check if the previously computed value you have. So what would you think regarding the time complexity for this?
I think the recursive approach would be 2 to the power n, if I'm not wrong.
And t of n will be equal to t of n minus 1 plus t of n minus 2, right? So
Right.
I'm not sure. I have to calculate it.
This is sort of a tree-like structure, right? So
A tree
in
like
that
structure.
case,
Yeah.
yeah, so by that logic, it is usually 2 to the power height of the tree. So by that
Yeah.
logic, should be 2 to the power n.
At every level, you'll have nodes as 2 raised to the power L, right? At every level. You are taking, can you repeat? You are taking directly the height of a tree, right?
Yeah.
So height of the tree in the worst case would be order of, I mean, n. If it is a skewed, let's say.
Yeah, right.
Yeah, I think then in that case it should be 2 raised to power n. But what they have mentioned.
You can like
Yeah.
calculate the complexity by writing the recursion equation.
Yeah, I have to solve this by substitution method,
Yeah.
like replacing.
Yeah.
Yeah.
So like that's how you should ideally do in an interview.
Interview, yeah. Otherwise, I think it should be like n has to be replaced by n minus 1, right? And this will be replaced by n minus
Yeah.
2, and this by t of n minus 3. With the base condition, I have to take like if n comes out to be 0, then we'll return 0 in that case, right?
Yeah.
And yeah, okay. I think I have to solve this one and then. Okay. Yeah, somebody was sharing, I think.
Yeah, I can share.
Yeah, sure. Go ahead.
I can see.
Yeah.
So if n is less than 2, I return n. Otherwise, I have 3 variables, 0, 1, and n node. And then going to loop from 2 to n.
Yeah.
And then I make n node and then reassign those tailing 2 variables to the n node. And finally return the tailing variable.
So here it's only order of n, right?
Yeah, order of n. And space complexity wise, it's order of 1, right? Because
Yeah. You are not using any extra space here. Only 3 variables for storing.
yeah, so in first loop it will be like 0 is 0, 1 is 1, and then when we reach for n node, which is 2, in that case 0 plus 1 is 1, and then and then I move my 0 and 1 to variable 0 and 1 to this number, and then in third loop my n node would become 2, and then I move my 0 and 1 to the next step. So 0, 1, this number becomes 0 and this number becomes 1. And then I return whatever was 1 is having at the end of the loop. That would be my answer. So in the third loop, it would be like 3, which would be like n going on here. And then in my fourth loop, it would be 5, like so 5, and will move here, and then these 2 tailing variables will move. So likewise, and then finally I can return whatever that the first tailing variable value is. That's it.
Yeah, okay.
Any question?
Somebody has, they should. Okay, we can switch to next then, if no doubt. Okay. So our next is. Sorry. Open up one year. Yeah. I think some background sound is coming, right? If somebody can, yeah. Yeah, we can return, it's like we have to construct BST from pre-order traversal. We are given the root node of a binary search tree, which matches the given pre-order traversal. And they have given the definition like a binary search tree is a binary tree where for every node, any descendant of node dot left has a value less than node dot val, and right will be greater than the node dot val. And also recall that a pre-order traversal displays the value of a node first and then traverses node dot left and then right. It's guaranteed that for the given test case, you'll always find a BST with the given requirement. So this is our pre-order traversal, and corresponding to that, this is the BST that I have created from that traversal. And constraints are like will be less than 100, and pre-order element will be less than again 10 to the power 8, and values of pre-order would be distinct. No duplicates will have in the array. Yeah. Yeah. So any queries or approach in this? How do you proceed?
So here the first node is the root node, and then you go to the left and the right. So given this like 5, so we have to
Okay.
find 5, and then we have to find 10, which is my next node.
Yeah.
So and the tree, it may not always have like two nodes, right? Like it can be either 1 or 0 node as well, as a left child or the right child.
One node or zero node I didn't get.
I mean, like the 10, right? So I mean, it's not a full binary tree.
Yeah. Yeah. Okay. Huh.
Um,
Yeah, we can take a root node and see the next element. If it is less than the root node, then take a queue and add it to the left, kind of left node to that. And if it is greater than, sorry, I didn't do the code, but yeah, just my intuition. So if
Yeah.
it
Yeah.
is greater
Got it.
than
Yeah.
root, then add it to the right. We need to keep on loop doing this until the end.
Yeah, I think this problem was
think
also
like,
part of.
I mean,
Yeah, sure, go on.
so think like, I mean, if you guys actually, yeah, so if you guys have solved the problem to verify whether it's a valid BST or not, so think like that. So what do you need? How do you actually do that if you have solved that?
Valid BST
The
on
same
left.
approach you can apply here to build the tree.
But in valid BST from left, we'll find the maximum, and that should be less than your root. And from right, we'll find the minimum, and that should be
Yeah,
greater
so
than.
when you have to build, so here in this case, for sure you,
I
yeah,
have an
so that will be
approach.
your termination condition when you will go with the input array. So when you have to return that, there is no more for the left side.
Yeah. Huh.
Yes, please
Yeah,
share your approach.
Okay. Sure.
yeah, I think this problem was also part of the 30-day lead code challenge. So I remember this.
Yeah.
I think the way we solved is like initially maintain a stack, right? Which basically has just the root node, so 8, and we iterate through the array elements, and we basically check if the next element is lesser than what we have at the very last element of the stack, so which is 8 in this case. So in that
Yeah.
case we just append it to the left of that node, so 5 comes to the left, and then the next node is again 1, so again it comes to the left of 5. So we go on like this, but as soon as the condition breaks, like 7 is greater than 1, right?
Yeah.
So we just pop out the elements from the stack. That is, we pop out 1, we
Yeah.
pop out 5,
Hmm.
and save it in a temporary variable. So 5 is the 5 gets saved in the temporary variable. And when we come to 8, we realize that 7 is less than 8, right? So we
Yeah.
basically append 7 to the right of the to the node that we just last popped out, that is 5,
Okay.
right? So it comes to the right of 5. So as of now, the stack only has 8 and 7.
Yeah, go ahead. Somebody has. Yeah.
Do you want to share your screen and show?
Now I'm logged in from my mobile, I'm sorry.
Oh, yeah. Okay.
But yeah, that was the overall approach. We just keep, we set the nodes to left and right depending on what is the last element in the stack.
Mm. Mm.
Okay,
Yes.
so if there is a right node to 1, suppose 2, right? So what will happen in that case? Like 8, 5, 1 will go in the stack, and then you get a 2. So so you pop the last element. I mean, I'm just taking an example where there's a right element to 1, which is 2. Okay.
Mm. Yeah.
So we keep on adding to the stack 8, 5, 1, and then we get a 2, which is greater than my last element. So I pop 1, or I just put it on the right of 1.
Yeah, we pop out 1 also, because the reason is, once you have something to the right of 1, right, that means the 1 node actually is filled. There is no element that can be associated with 1 anymore. So by that logic, we pop out 1 also.
But we have
And
to
yeah,
insert 2 in the right of 1, right?
yeah, exactly. So when the loop ends, when you pop out the elements, the very last node will be linked to the right of 1, right? So after popping out, you actually link 2 to the right of 1.
Okay. Okay. Yeah, I think we could try this.
And and one more approach, like it's a BST. If you sort it, the pre-order whatever they have given, you can get in order traversal. Like you'll get a sorted array, which would be the in order traversal, right? From this array, like that. I did one. I'll share it. Like let's say if we have this array. So if you sort them, you'll have 1, 5, 7, 1, 5, 7, 8, 10, and 12. Now we got the in order, and this is, we know, pre-order. That means the root will start from here. So if first 8 is your root, then you divide this in order into two parts, 1, 5, 7, and 10 and 12, and recursively again work on this. Now next node, now you remove this element out of the, what do you say, pre-order array. You'll get 5 now. Now once you have 5, you can again this array 1, 5, 7 will be divided, 1 on the left and 7 on the right. Again you can remove 5 out of it, and 1 will be there, but you don't have any left, neither you have on left nor on right, so it will be left, and so on. Recursively you can do that. Is one way. I mean, any doubt in that method?
So, but you have to convert this to the sorted array first, right?
Yeah, I have to convert it sorted to make it in order, because every in order sorted array or BST will give you in order traversal.
Right, right. But that becomes a different problem then. Like if you're doing a sorting, then it becomes a different problem, that you have a sorted array and then you convert this to a BST.
Yeah.
I'm not sure if that will be, that is what the interviewer will be looking for.
Yeah. I mean, yeah, but yeah. But actually, I think it will take more time complexity. First, we'll sort it n log n for that, and
Yeah,
again,
exactly.
recursively, you'll have to do like.
This is like more of a brute. I mean, I wouldn't say
kind of
both,
brute
but
force.
I
Bit
mean, we are doing
improvised.
two. Yeah, we are trying to do two different uh, process to solve the problem.
Yeah. Hmm.
Yeah, the other approach which I remember, I think I did this a long time back, where you pass an index for the index of like 8 as 0, and until you hit a element which is greater than the current element, you keep on incrementing the uh,
Yeah.
index, so that becomes the left node of, like, for 8 is the left node. Is this the same approach what you
Yeah,
have?
yeah, yeah, exactly. What I did, I first popped 8 out of it. I mean, took 8 as a root. Now I'll go for the index. I'll not stop till the moment I get element greater than 8. So
Oh,
my,
okay, yeah, this is the
yeah,
same
yeah.
approach I was
So
talking
I'll
about.
reach up to here 7 because if I stop at 10, you'll find that 10 is greater than 8. But up to this 5 and 7 will lie to the left of it. So this is what I have done. I mean, I'll go till the point I find the element at the ith index is less than your root. Your root is 8 and we'll run till the point we find element less than 8. So that will be your left one. And after that, remaining will be your right one. And subsequently, again, recursively, you break that. Again, 5 will be your root. Then just check which element. But here, you won't find no, up to I again, up to again 1 you can go. So 1 will be your left child for this and 7 will be your right child.
Uh,
Yeah.
Yeah, but
Then
I don't recollect, like, how do you decide after 1, like you get 7, which is greater than your root, right? Because 1 becomes your root here. At After you traverse through 8, 5, 1, and then 1 becomes your root. So you go to 7, which is greater
yeah.
than 1, right?
Uh, so
Uh,
I
so what
won't
is the
take that
logic
index.
to insert, like, where the 7 will go? Whether
Yeah,
7 can go right of 1 or the 7 can go right of 5?
yeah, wait, I'll see.
And how do
So
we
first,
know that it's a 1 node or a 2 node? Like, uh, as I was saying earlier, like whether it's a left child or a right child, or it has 2 nodes.
yes.
That is
So
something which I'm not able to recollect.
so you first took 8 as a root. 8 I'll pop out. I mean 8 I'll take as a root. Okay. Then to the my this BST pre-order will start from 1, 5 to 7, right? 5, 1, 7 it will contain, and your right child will contain 10 and 12.
Mm-hmm.
Now similar process will repeat on it. 5 will be your root. Now when 5 is your root, so you will stop where uh, up to 1 only you will go, because 7 will be again greater than that 5, right? And the remaining right child will be your 7. Right will append to this, and again 10 and 12.
Right,
Now
right,
10
right.
is your, so 10 and 12 will be your this.
Got it, got it. Yeah, I think
Yeah.
it makes sense now. Yep.
I think somebody has written something in chat. Yeah. Uh,
Yeah, this is the solution I just pasted from my editor,
okay.
which I was
Maybe
talking about.
it's not. It's not opening chat. Okay. So you have posted there, right? That stack one, isn't it?
Yeah, right.
Okay. Okay. So any queries in this one?
So the complexity for both the solution will be same, right? Because this also uses a stack, but there is no recursion, so I think it's more easy to understand the one which is pasted on the.
Yeah, here it is implicit stack, so we are not using any extra space. But the one she was mentioning, she's using extra space. I mean stack. But I think time complexity of her should be order of n only, because each only one time she's visiting, right?
Yeah, right.
One passage, yeah. So I think time wise yours is good at the cost of space, but here I think again same tree method you have to use. T of n equal to t of left plus t of right, and then calculate. I'm not sure, like we need to check it. Or anyone wants to share any other approach other than this?
So what would be the time complexity of your solution, Shashank?
Yeah, what that is what I was checking. Like
2
T
raised
of
to
root
n? Like,
should be, I'm also not sure. It should be like how much you have on the left and how much you have on the right. That is the recurrence equation that will get out of it, right? Now in worst case, so this should be, we have to
I
calculate
think
this.
again it should be 2 to the power n, because the recursion that you are following.
Yeah, it will be in worst case should be like T of only one child on the left, and on right you'll have T of n minus 2, because one will be root and the right child you'll have T of n minus 2. This is the recurrence. So it should be order of n only, right? This one?
Yeah, I think it should be order of n, because for that input array, you are going only once to the each index array, right? You are not
Yeah,
going more than once.
once. And even if you solve this one, you'll have order of one only. It's a linear time equation only.
I mean, when you say linear, yeah, right. Big
No,
O of n.
So I'm not sure on the Python side, but how it handles, you're kind of splitting the array into two. So,
yeah, sure.
and there is a while loop, which I know it just incrementing variable I, but again, in terms of bigger complexity, it is still considered like every time you are progressing your I to half of your array size, at least, like, or
That
the
that's
whole
the
array.
best case you are talking. I mean, equal. You are saying equal, half on left, half on
Yeah,
right, right?
right.
But the
So,
worst case would be this only, no? Like one on the left and one will be your root, and n minus 2 will be on your right side.
yeah. So in that case, your while loop is going for n times,
Yeah.
line 16, 17, and then there is a array split that is happening. So I don't know the language wise Python, how does it handles that.
Yeah, I think this while will, I mean, should be while loop on one also. This also you have to add.
Yeah,
Also solve this without
that,
with recursion, but no while loop. Just the approach what I just shared, that the
BST.
min
Oh,
max. Yeah,
uh,
based. Yeah, I
yeah,
solved using that.
you can share it. I think.
Okay. Yeah.
yeah,
Yeah,
the O of
yeah.
one on while loop is for again number of recursions. So it's not straight off n.
No, this recursion is outside your while loop. It's not inside the while loop.
But then your while loop is reoccurring a number of root and number of like number of left and number of right, because you are calling that
Yeah,
BST from pre-order again on the left hand.
exactly. Yeah. Should, it won't be directly order of n, but
Yeah.
each time it's decreasing also, right? If it is n, then next time it will be either half n by 2 or something like.
So would it be like n into n factorial, something like that?
N into n factorial will be again too much, right?
Sorry, worst case scenario is your line number 28. That would
Yeah,
be is into like O of n again. Your
yeah. If we
while,
solve this,
yeah.
I'll check. I have to check that. Okay, Praveen is sharing.
So it is n squared then.
And oh,
Yeah.
okay.
Should be off.
Of n. I don't know. I have to we solve it.
I have one query. If you take,
Can I
say,
see my screen?
Yeah.
yeah, so if you take one of the average cases where like
Okay.
there are equal nodes on both of the sides. So it's like t root is equal to, I mean, tn is equal to tn by 2 on the left side and tn by 2 on the right side.
2t n by 2. Yeah.
Yeah, so what would be the complexity in that case? Wouldn't it be like 2 raised to n? Like,
Should be log n factor will come because you are dividing it by 2.
because it will be like n by 2 plus then n by 4, then n
N
by
by 4, exactly. Because of
then
that,
n
only
plus
log
n.
factor will come. So n by 2 plus n by 4 up to n by 2 raised to the power n, right?
Yes.
So
So,
if you
so the
n
sum,
log n something, yeah. So what is the sum of this? 1 plus 1 by 2 plus 1 by 4 plus 1 by 2 raised to the power n?
I've forgotten some of that geometrics. I mean the
Yeah, I think it should be log n only because all the elements are less than 1 only, no?
I think it's often, yeah.
Hmm. Okay, let's check.
Yeah.
Okay, let's first up. Yeah.
Yeah, so I was talking
it
about
will come
that.
out to be 1. Yeah, it will be come out to be 1. So it will be order of 2n or like n.
Some constant order of.
Yeah.
Okay. Okay. Yeah, you can explain.
Yeah, so here I'm passing that what is the minimum value for this particular node and what is the maximum value for this particular node. So starting with the root, so the maximum on the left hand side should not be more than the current root
Can
node,
you
right?
increase your font size, please?
Let me. Oops. Is that okay?
Thank you.
I don't know if we're going to actually find anything.
Pardon, I think.
Did you say any? Did someone say anything? I
Yeah, I couldn't understand what.
Yeah.
Okay, go ahead. I think.
Yeah. So at each level, when I'm trying that, so I'm passing what is the minimum value on that side and what is the maximum value.
Yeah.
Yeah, so I created the root node here, and when I'm building the left side, so I know that the maximum value for on the left side will not be more than this particular root node, right? And the
Okay.
same for the right side. And I'm doing at the same each level when I'm going to build a child for that node. So I'm passing that what should be the maximum value for that on the left hand side, and what should be the minimum value on the right hand side. So that's what I'm doing here recursively.
It's similar to that, like min-max approach, right? The min
Yes.
value.
Yeah. This is the same approach. One of the approach what we use to verify the BST.
Yeah. Exactly.
Yeah. Is there any question about this?
I think no.
What is the index? What is index here?
Index is the current element I'm processing in the array.
But is it changing? Oh, okay. So it's 4 times there are calls. So yeah.
It's every time because I'm moving into the input array and changing my index. What is the current element I'm processing? And based on the current min max, I'm deciding whether I should go on, whether it's a valid value or not. If it's not a valid value for this side, then return.
Yeah. Okay.
Okay, I'll stop the sharing to you, Sashank.
Yeah. Yeah. So any queries here, or we can switch to next. Yeah. Okay. Then let's move to next. Yeah, this is transformed to chessboard. An n cross n board contains only zeros and ones. In each of the move, we can swap any 2 rows with each other or any 2 columns with each other. And what is the minimum number of moves in order to transform the board into a chessboard? And chessboard, they have defined like a board where no zeros and no ones are 4 directionally adjacent. And if it is not possible, we need to return -1. So if we look at this, So what they did, this is your initial matrix, sorry, 0, 1, 1, 0, this. So first of all, they have one first move is to swap first and second column. So 0, 0, 1, 1 and 1, 1, 0, 0. They both are swapped. So in place of 0, you'll have 1. And in second move, they have second and third row. So this is swapped with this. Now when you come here, if you pick any element to their adjacent, you won't find. Let's pick this 0. Then left, right, up and down, you won't find any 0. For this 0, left, right, down, you won't find any 0. So it satisfies the required condition, whatever they have asked. Same goes for this. Like here, no matter what sequence of moves you make, you cannot end with the valid chessboard. Yeah, because you can't do here in this case. And yeah, board will have the number of rows and columns in the range 2 to 30, and it will consist of only zeros and ones. So any queries in the question?
So here the rows must be swapped, right?
In the first example, you're saying?
The overall, like it's just the rows we need to.
Either row or column.
No, row or column. Yeah,
Okay.
both.
And only adjacent.
Adjacent, yeah.
Oh, got it. Thank you.
No. Yeah, any approach in this? Like any? Could we use DFS here to check whether adjacent position is 0 or not, and whether same or not? If it is same, we can replace it 1, because entire matrix is filled with zeros and ones only.
Could be. What we have to transform here?
Like you have to make this matrix in such a way that, let's say if you focus at this 0, it's left, right, down and up. Since you don't have any up, all should be 1 only. It shouldn't be 0. You focus it at this 0, its left is 1, right is 1, up is 1, below is 1. In all the 4 directions, it should be different than the current.
Okay. So...
But restriction is like we need to look only for the adjacent. So I don't think so DFS will work here. I'm not sure, just asking. Or anyone with any other idea, like any other approach somebody followed?
Oh, not try that.
Okay, then let's. So here, what is like what I couldn't solve it. I saw the article, and then what I found, like, so they are saying that yeah.
Please.
Okay. So what is this, like this is the original matrix that are given to you, and you have to transform the matrix in such a way that all the adjacent 4 sides should have the different element than the mid one. So that can be possible only in 2 cases. If you're this row, what you say, if you're this first row, 0th column is same as the 0th is same as the first column, or they are inversion of each other. Only in that case we can what we can do, only in that case you can make those change, only you can make those changes, invert each other in order to reach to the final stage. Or you can have, if you're this row, first row and second row both are same, or second row is an inversion of first row, then only you can make changes in order to reach to this approach, in order to reach to the final destination. Does that make sense, sir?
Yeah.
Uh,
So you make the decision at every row whether to swap with a column or a row.
row. Yeah, exactly. Yeah. So that is that is the first crucial point. Next, what you have to, how will you swap it? So two patterns are created with this. It's like whenever you find,
Sorry to interrupt. Can you repeat your last point?
sure, what yeah, what I was saying is like only there will be only two possible cases in which this chessboard would be solvable. It's like when you, this is your first column, okay, 0 0 1 1, and next column is 1 1 0 0. If they are, if both of them are same, then only it is solvable. All first column or second column is a inversion of first column. Like if it is 0, it will be 1, here 0 1. If it is 1 0, if it is 1, then it will be 0. Does that make sense? Like, or you can see, let's say if this is your original row is given to you, either your second row is same as the original row, or your second row is the inversion of the original row. Then only you can make, or in column wise, if you see, if this is your first column and this is your second column, if both are same, then in that case, or second column is the inversion of first column.
Okay, but is there any proof of that? Because it kind of sounds like, you know, something that you come up after many hit and trials or something like that. How would you come to that approach naturally? That's my
No, I
question.
have seen that. It's not my approach. I have went through the article and
Exactly.
they
Yeah. Yeah, even though, you know, let's say you get this question in the interview, then it's hard to come up with that kind of approach naturally. I was looking for something, a natural hint uh, behind your theory that you just said. I don't know.
natural what
Not intuitive enough. Yeah.
it's not what intuition. At first when I saw the problem, my first thing was like go for a DFS. I mean, you have seen number of island problems, right? Like adjacent ones are there
Yeah,
only.
right.
So
Yeah.
that was the intuition to my brain. But once you read this, what they are saying, like you can swap any two rows. Some background sound is there. Yeah, you can swap any two rows or any two columns. Then in that case, you won't be able to go with the DFS. This is the pattern they found out. I also don't know how intuitive it is. Like on what basis? It's like I'm remembering or grabbing it. But once you look for the final, then you'll realize why they have gone for this.
Yeah, okay, maybe.
Okay, let's check. So what they did, they started defining the row as positive and negative. Now, what was the definition for row as positive? If your original row and your next row both are same, that means it's a positive row. Else if it is first one is the original one, and if you go for the inverted one, if they are they are inversion of each other, then they consider it as a negative row. These are the two definitions that are formed out of it. Again, it's not intuitive, but I don't, let's see, let's go ahead. So what they did, it's like after yeah, so now what they'll do, they'll check so if your n is even, like if your length is even, then you'll have equal number of positive and equal number of negatives, where 0 will stand for positive and 1 will stand for negative, right? And if it is odd, then there will be a difference between like I mean odd number and even number. There will be a difference between, if the entire length is odd, you'll have difference between positive and negative. They'll differ by one number of positive and negative. So this is the pattern that is generated out of it, like 0 for positive. Pattern A I took is like alternate positive positive negative, and pattern B is like negative positive negative. Now how will you find that which of the pattern is being followed in your question? So for that, like we'll take the first row and we'll check for the next row. If they are same, then this for every row, for every 0 you'll put negative, and for every 1 you'll have positive. So let's say this is your initial problem, and this is the pattern that I've decided for it. I'll match with each of the patterns, like this positive matches with this negative. Then since they are not matching, sorry, so you'll have one error. Negative matches with, so negative, so it's okay. Then positive matches with this, but this negative won't match with. So again, you'll have error. Whenever you have your error is odd, then in that case, the pattern what you have decided, that will fit to your problem. Else, if you find your error is even, then the pattern this pattern would be suitable for this. So this is what I followed in the code. Like I calculated all the positive and negative rows. I mean, this is for calculating all row positive. This one like 0, 1, 1, 0, and this is for your column. And just for calculating the negative, I'm adding 1 to each of the elements and taking the mod of it. So if it is 0, 0 plus 1 will be 1, and you take mod of it, it will be 1. So it will invert it to 1, and 1 plus 1, 2. If you take mod of it, it will be 0. So this is the row negative for that. And this function will be called, what will happen here, you'll take each row each line you will take, and you will compare it with its next, whether it is a positive or negative. So these are all the 4 rows, and these are all the positive rows that I've generated out of it based on this. Like if it is same, if your second row is same as that of the first row, then you'll have positive, else you'll have negative in that case. Similarly, I've generated it for again for all the columns. If these 2 columns are same, then they will be positive. If they are different, then they'll have negative. And this is just checking for the odd cases, checking for the even cases, and out of these two, these are the 2 pattern which are possible: positive, negative, negative, positive, and whichever is minimum out of them, I'm returning for that. It's this, like this intuition, I myself is not getting, like how did they come up with this, like this original, and if they are same or if they are different. So if anyone can come up with this, like saying if any.
What would be the brute force approach like for this?
Brute force would be like, you'll check all the 4 directions you have to go, then DFS only, no?
Okay.
Because DFS is by which only you can go in all the 4 directions.
But how are you thinking that, I mean, that brute force DFS here?
Like it's in island problem and all, we check whether adjacent element is same as the center one. We are at 0, standing at 0, and I'll check to the top whether it is 0 or not. If it is not, if it is 0, then I'll make it 1, because your entire matrix contains only zeros and ones. So by this, I'll check to the left, I'll go right and down. I'll check whether it is same as the center one. If it is same, then replace it with the opposite, like 1, or else. Or what should be the brute force? I mean, other than this, that's not.
So if we go with that, so it might be for one particular row and column, that is true. But when you move forward and you in the same row and in same column,
yeah,
you found that these are not the same, or condition is not valid, then you will either change the row or column. So that may actually impact your previous result.
I think I'll have to mark somewhere visited that if I have already seen that, then I won't make changes to it.
Yeah, I think because you swap only a cell, right? It's not really swap the whole row or the whole column. So it's hard to prove it. It's correct.
Yeah, I'm cell only. I'm checking. Oh,
Yeah, but we have to flip the row and full column.
yeah, that.
I think the brute force would be like, check if it's not valid, then we could, swap, swap all the configuration, swap all the row, swap all the column, and check. Every time we swap, we check if it's valid, if it's not, swap again.
So you are saying that every time we swap, we have to start over and start the validation again?
Yeah, yeah.
Yeah, makes sense.
One observation is the leftmost starts with 1, right?
Top leftmost or
Top, yeah.
No, it's 0.
I mean, the result.
Okay, huh? So is it always true? Will it be always like this?
No.
I'm thinking.
I mean, this is an example. I mean, if you just change the value in the same matrix,
Yeah.
so your result will be different.
If I make 0 as ones and ones as 0, I think it will invert.
Yeah.
This the four corner, does it have any relation?
4 corners. Yeah, they are inversion of each other. 1, 0, 0, 1. You're talking this 1 and 0 and 0 and 1, right?
Yeah.
4 corners.
Like
no, because n cross n, right? So that may change. So here this is actually 4 cross 4. If it's 4 cross 3, then it will be 101.
It's a chessboard. N cross n, it's mentioned.
Oh, it's n cross n minus. Okay, yeah. Then it may.
So because it n cross n, it even, right? So we think about like, every
no, it
the
could
odd
be
and even.
Yeah, it could be anything.
The odd and even complement. I mean opposite, and then somehow when we get to the bottom row should be somehow similar to the second row. In this case, look like it is, right? The second row 0, 1, 0, 1, and the bottom is also 0, 1, 0, 1.
Maybe that is good in this example, doesn't fit in.
But if we think about the relationship between the first row and the second row, and the third row have to be like the flip of the second row.
Looks like, I mean, if we think like you are thinking, so even there will be some difference in even and odd. So in case of odd, so you see that the first row and the last row will be same, first column and last column. In case of odd, the first row and last row will be same.
Right. Yeah. And if it's even, then that will be the same as the second row. And if I think if we think about that way, we can make the same assumption for the column. The first column and the last column
are same. In the result you are telling, or in the original one? In the result.
In the result.
They are inversion of each other.
Yeah, because this is the it even, right? If it odd, then the first column would be the same as the last column.
Yeah.
If n is odd number.
So first of all, can we validate that whether it's possible or not, just counting the 0 and 1?
Like
And if they are not equal, then it's not possible to transform.
in the entire matrix you're telling.
Yeah.
Yeah, I think at a row level and column level, we can just validate and return back, right?
That's a base case. Like, I mean, if such, okay, then let's say if it is valid, then.
No, I'm just thinking aloud that, I mean, how can we narrow down the problem?
Yeah, exactly. Yeah, makes sense. And graph we can't use, right? If we take each cell as a graph and then some.
I don't see any relation immediately that can help us.
Maybe we can think like, let's solve it for n equal 2, right? And then do it for n equal 3. Maybe we can find a pattern.
Okay, this is n equal to 2 cross 2, you're saying, right?
Yeah.
This is 2 cross 2.
That is invalid, right?
Yeah, it's an invalid. I mean, one here should be 0.
That's invalid and not possible to transform.
Yeah. First line. Yeah, let's say this is the case.
This one is valid, right?
Yeah, this is valid.
So in this case, we see the first row flip of the second row and the first column is flip of the second column.
Yeah, when n is even.
So if we actually split them in a 2 by 2 square and see if diagonals are same.
So if you said that like 1 0 0 1, like is that like you should always have a combination of like a couple of keys like 0 1 and 0 1. If it is like 1 1 0 0, it doesn't even work, right?
I didn't get.
So if your example contains 1 1 0 0, so I mean we cannot even get the answer, right?
This is one row, right? It's just only one row.
No,
that's not
there's like four rows and one of the row is like 1 1 0 0.
It depends on what is your other row, because you have to look for the adjacent position. Then only you can decide like whether it will be valid.
Let's say if you have 0 0 1 1.
0 0 1 1. So you want to check whether this is valid or not, right?
Yeah, that's possible. I think if we just swap the middle two rows, two columns, sorry.
Yeah, then it's possible. If you make it this as 0, this is 1, and this as 1, and this as 0. So once left, right, down 0, yeah, it's possible then.
Okay. Oh man.
Yeah. 1 0. The diagonal also works, like all the diagonal after once it is sort, I mean in a proper manner, then all the diagonal will be equal. 0 0 1 1.
Yeah.
Why is this example not valid? 0 1 1 0.
This is valid. 0 1 1 0 is valid.
No, the output is 0 for that, right?
That means there is no need to transform. It's already valid. No need to swap anything.
It's a valid chessboard. Yeah.
The output what we have to return is that number of swaps.
Minimum number of swaps. Yeah. I think we have to check for this, and then if somebody comes up with some pattern is only hiding here, which we are not able to guess it out, I think. Because
did we explore this concept? And I think somebody said it already. The diagonals should be equal, right?
Yeah.
So just like the chessboard, if you have a black on the top left, the diagonally all the elements should be black, right? So by that logic, if we go through the first row, and if you are sitting on the leftmost element 0,
okay,
so we can actually see which of the rows have a 0 in the diagonally positioned manner. So in this case, second row doesn't qualify, third row qualifies, also fourth row qualifies.
Yeah.
So at least we maintain which rows we can swap with. Similarly, again, we search the 0, right? Then we move to the next element, 1, and then we see which rows qualify further. I'm just thinking, like, can we just follow that approach?
So for this, so first row, first one, for them the diagonal will be second row, third one, right?
The diagonal would be the second one. I mean, the first one that you see, 0, 1.
Oh, this one you're saying.
Yeah, diagonal would be that only, right?
This diagonal element will be for 0.
Yeah.
And I'm saying for the next one, I'm saying.
Yeah. For the next one, it would be the next one. Yeah, this one.
Next one, yeah.
Yeah. So even though this row qualifies, but we already rejected it in the first swap.
Swap.
But if we think about the answer, somehow we were supposed to. What happened here? Did we swap it with the? Okay. 0.
It's somewhat related to chessboard only, but if somebody.
Okay, I think it maybe go back and think about the idea that Shashank was talk about the row, this row and the next row either that have to be the same or have
inversion.
to be flip of each other, and why that condition have to be true. Then maybe we can find a pattern there.
Yeah, but that intuition I'm not getting. Like if you're, I mean, only two cases are possible. If your original and first row and second row are same, then only you can make it solvable. Or if they are inversion of each other, then only in that case. What's the intuition behind that? That I'm not able to get.
So let's say look at the example, right? The first example we have on the left right here, and we see the first row, and let's look at the first row and the second row. They are the same.
Exactly.
Right. Right.
Yeah.
And then that would mean the second row and the third row have to be either the same or flip, right? In this case, it's flip, right?
Yeah, it's flip.
And because of that, then that means that if we flip the third row to the second row, then now we see it qualify for the
next round.
The next round, right?
It makes sense.
Because the second, now if we flip that.
Will that work for odd also 3x3? This is for 4x4, right? 4x4, right?
Yeah. But 3x3, if we think about that way, if it work for the row, then we think it's gonna work for the column. But think about the row first. So let's say we have 4 rows with exactly the same, then
5.
Then it's not gonna work, right?
Yeah, in that case, I think again that will be.
Yeah, if we have 4 rows 0, 1, 1, 0, 4 rows exactly the same, then doesn't matter how we flip horizontally, it's still the same.
But yeah. With this part is clear.
Then how it worked? Is that the only condition that they mentioned?
Yeah. Only like either your these two should be same or they should be flip of each other, either in case of row or in case of column.
Yeah, but then it should work.
Okay, let's take the example and then I think.
Yeah, let 0, 1, 1, 0 repeat 4 times.
Okay. What are you saying? 0?
0, 1, 1, 0. Yeah, repeat it 4 times.
Okay. Four times, right?
Yeah.
Oh, sorry. Yeah.
You have it 5 times.
Oh, sorry. 4 times. Okay. Okay. Yeah. So your first is same as the second. First row is same as second. Then
I think when all the rows are same, you can do a column swap.
Column swap will not column swap will not make any change in the row.
Yeah, but it would work, right? We swap the first and the second column and it works. Yeah.
But that's again a special case, right?
No, if we check, we check the row first, and then if it are the same, then we go for the column.
And if column are same, then we check for rows.
Yeah.
Sorry, so if we flip the column 1 and 2, it's not going to be checkboard.
Yeah, again. If you column, if you flip one, it should be 1 0 1 0, then 1 0 1 0 1 0 1 0 1 0 1 0.
Yeah.
No, it's not working. See, because
actually our initial base case itself is failing, because initial base case we thought like in a column or a row it should be equal number of bits, right? Yeah, here
they are equal. In row they are equal.
Yeah, but in column they are not.
Yeah.
So the base case itself is failing.
Maybe every 2 rows next to each other, if they're equal or inverse. What if we try, I don't know, the second and the fourth one to do the inverse of the
second and fourth. Second and fourth are row or column, you're saying?
rows. Let's say the second one we make it 1 0 0 1.
Okay. Wait, let me copy that. Let that be there. 1
0 0 1.
Yeah.
And then the last one 1 0 0 1. Okay. So let's swap 1 and 2.
Column.
The column, yeah, column 1 and 2. So what do we get? 1
0.
Then 0 1. Yeah, this one will work. So maybe every adjacent row, if it's inverse, no, that's not gonna work. What if this works, but
that diagonal is
Is it like I mean our immediate row should be, if it is like immediate row is same, the column should be inverse, right? Is it something?
Immediate row is same. Let's check one. Sorry. Immediate row. Let's check 1 0 1 0. So what you are saying? If immediate rows are same, then
the columns should be inverse.
Right. If you inverse the column, it will be 0 1 0 1.
No, I'm saying like even before continuing, like that should be our base case, right? That's what I'm saying.
Yeah, I think
because we were able to achieve the answer with the previous example. The rows were the immediate row was same, but the column was like inverse.
Inversed, yeah, yeah. But again, for different problem, it's different rules are setting. Like,
yeah, it's more like I think finding right examples to come up with the logic.
Yeah. Otherwise, for this, something your will work. For some others will work. what could be the intuition behind this?
So definitely one of them is that if every row is the same initially, you can't do it. I guess.
This one of the condition it is like, but that won't be everywhere. You won't have like this, right?
Yeah.
Yeah, it's again specific to the problem.
Yeah. I guess we need to go back to math.
Yeah. Then check. But
Matrices.
one thing is like all the transform are having the diagonal elements as same, right? I mean, once it is fully transformed in a correct, if it is a valid one, then all the diagonals are same, diagonal elements. But from that, what conclusion?
One small, like, I don't know, just thinking.
Yeah.
So if we think as a binary numbers, then first row and second row and will be like 0, right? Like all the rows, I mean any rows actually, the and will be should be 0.
Yeah,
like 1010 and 0101 is 0, right?
Yeah.
I'm just thinking, can we proceed in that way, something like that?
What can that give us?
A binary and I meant.
Yeah.
I'm just getting multiple ideas. This is one of them, and other I was thinking like start from leftmost and then check diagonally if it is equal or not.
Yeah.
It should be equal, and then the corresponding row and column should be not equal to that value, like 3 directions from the leftmost.
Yeah.
Something like this
But
too.
again, I think that will.
That's kind of a DFS, yes.
DFS, yeah. I think let's look up for this. If somebody comes with some ingenious idea, can share it in the Slack.
Yeah.
Yeah. Okay then. Okay, thanks.
Thanks, Shashank.
Thanks,
Thank you.
Praveen.
Thank you. Thanks, Praveen.
Bye.
Bye.
Bye.